Welcome to my YouTube channel. Today we are not going to discuss any particular question. We are just going to discuss a topic, partial fractions, of which I've labeled it to be part 1. There are 4 parts, so the videos will follow each other. Today, the first part, which we are going to discuss, let me read through. For a proper algebraic fraction whose denominator has 2 distinct linear factors, a partial fraction is given by px plus q over ax plus b. This is the same as, or it is equivalent to a over ax plus b over cx plus d. And this rule can be extended to 3 or more linear factors as follows. So in cases where we have got these are factors of a particular equation, so it means that these are linear in the sense that there is no variable in here which is raised to a particular power other than 1. That's why they are linear factors. So it means that we can split this into a over this plus b over this plus c over this. Now there are some terms in particular which you really have to pay attention to. Proper. This proper is coming from proper fractions. We know that proper, what does it mean with proper fractions? When we talk about proper fractions, we are saying that the numerator is smaller than the denominator. That's what it means. Whose distinct linear factors, again there is a word linear. So you have to be mindful of these terms. Because if the denominator somewhere is not linear, it will mean those factors are not linear, it will mean that we are talking about something different. I think I've already explained something about this. Now let us go to our example. Express 2x minus 13 in partial fraction. So how do we express this in partial fraction? The first thing we do is we write down the quotient of 2x minus 18 over 2x plus 1 x minus 3. So we are just going to discuss that this particular problem can be expressed as partial fraction in this form. So we are going to use the same rule here. So this is more or less like equivalent to a over 2x plus 1 plus b over x minus 3. You can see that I'm using these equivalent. These are equivalent symbols. Equivalent symbols meaning in this denominator it's possible that we can have expression which needs to be factorized. That's why we are using equivalent. Though at the end it has to be equal to, because we would have found the exact values for a and b. So what do we do first? What we do in order for us to work out this particular problem, we have to multiply both sides, because as you may be aware in mathematics, whatever we do on one side should be applied on the other. Yes, so now in this case we are going to multiply both sides by the denominator of this particular problem, by this particular question. So I'll be showing all the stages so that no one gets lost in this particular example. As we move forward, you won't be showing, because it would have been the continuation of what we are doing today. So, in the interest of ensuring everyone follows, I'm going to show all the steps. You can see 2x plus 1 x minus 3 multiplied by 2x plus 1 x minus 3. Someone might ask me, but why is this person using these squared brackets? Because they are already curved brackets in here. We can't use another curved bracket already. In mathematics, we have to order it onto. It's nice, so we use the other type of brackets. And this now is equal to, because now we are working out a divided by 2x plus 1 multiplied by 2x minus 1, x minus 3. Bear with me, I am working with space, so that's why now I'm reducing on the font. B over x minus 3. We are multiplying this by 2x plus 1 multiplied by x minus 3. So we can see that here, this divides this divides this, so we remain with what? 2x minus 13 is equivalent or is equal to now. This divides this, so we are remaining with a multiplied by x minus 3 plus, you can see here, this x minus 3 divides x minus 3, so we remain with b, open brackets, 2x plus 1. So from here, after this stage, there are two methods which I'm going to show you guys. So there is what I'll term as method 1. Method 1. Yes, so method 1. So for method 1, what you usually do is, you have seen 2x minus 13 is equal to a times x minus 3 plus b times 2x plus 1. So we just concentrate on what is in these brackets. So I'll get x minus 3, I equate it to 0. So this will give me x is equal to 3. So this is as good as us saying, when x is equal to 3, what would be the value of either a or b? So we get the equation 2x minus 13 is equal to a x minus 13, so minus 3 plus b 2x plus 1. So having written down that equation, let me substitute for x. So it will be 2, where there is x, we know that x now is 3 minus 13. This is equal to a, open brackets, x minus 3 plus b, open brackets, 2x plus 1. Oh, sorry, we are substituting where there is x. So 3 here plus 1. So having done that, 2 times 3, this gives us 6 minus 13 is equal to 3 minus 3, that's 0, 0 times 8, 0. So we just remain with this part, which is going to be, open brackets, 6 plus 1, close brackets. Right? So from here, we are going to have different signs. Subtract 13, take away 6, gives us negative 7, which is equal to 6 plus 1, 7 times b, 7b. Dividing both sides by 7, we get b is equal to negative 1. So having found b, we go for the other bracket now. Since we have used this one, so we use this one. So we get 2x plus 1 is equal to 0. And this will be 2x is equal to negative 1 divided by 2 divided by 2. Our x becomes negative 1 over 2. So from here we can see that we substitute now again from the equation. So 2, where there is x, this is as good as when x is equal to, we put negative 1 over 2, so we substitute with negative 1 over 2 minus 13 is equal to a, open brackets, negative 1 over 2 minus 3 plus b 2, sorry, use square brackets, because we already have square brackets here, negative 1 over 2 plus 1. So from here, we are going, this divides, we are going to negative 1, so we are going to have negative 1 minus 14 is equal to A. 2 times negative 3 is negative 6 minus 1 to give us negative 7 over 2. When you look at this side, this divides, remember with negative 1 plus 1, that's 0, so this cancels out. We will this part, grouping like 10 here, we're going to have negative 14 is equal to negative 7 over 2A. Now, knowing that 7 can divide 14, I wouldn't want this figure to become large, so of course I'll cross multiply. Then I'll have negative 14 multiplied by 2 is equivalent to negative 7a, because 1 times negative 7a is negative 7a. Then I divide by negative 7, I divide by negative 7. My a will be equal to, so we can see that this divides 7 into 14, we're going to get 2. 7 into 7, 1. 2 times 2 gives us 4. So that means that our A is 4. So having found the value of A and the value of B, we can see that our value for A, we found it to be 4. So we substitute where there is A. We found negative B is equal to negative 1. So it means that if we put negative 1 here, negative times positive is negative. So we're going to have 1 minus, sorry, we're going to have negative B over negative 1 over x minus 3. So this is the solution for method 1. Method 2. Method 2, we also pick it up from, so we pick it up from the same. We had this, remember. So now, what we do now here is to expand everything which is on the other side. So we have got 2x minus 13 is equal to, expansion means that this is multiplying everything inside here. So we're going to have ax minus 3a plus 2bx plus b. So having found this, now we can group any term which has got an x, and whatever has got no x, we consider that to be a constant. So we're going to, this counts as it is. So we're grouping ax plus 2bx minus 3a plus b. So we can see from here, we're going to have now 2x minus 3. We factor out what is common here. We are going to remain with a plus 2b x minus 3a plus b. So from here, again, 2x minus 13 is equal to, so since we have already expanded, means that now we equate whatever got x. So 2x is equal to a plus 2b, and negative 13 is equal to negative 3a plus b. These are constants. So in this case, this x and this x, they will divide. Remain with this. So we have an equation 2 is equal to a plus 2b. I can make a the subject of the formula here. A will be equal to 2 minus 2b. So having made a the subject of the formula, substitute it in the other equation. So negative 3, open brackets. A here is 2 minus 2b. 2 minus 2b plus b. So this negative 13 is equal to negative 6, negative positive 6b plus b this side. So here we are going to multiply 10 negative 13 plus 6 is equal to 6b plus b is 7b. So from there, continuing, negative 13 plus 6 is going to give us negative 7, which is equal to 7b. Then we divide both sides by 7. So we get b is equal to negative 1. Since a is already made the subject of the formula, here we substitute where there is b with negative 1. So this will give us 2, negative times negative, it's positive 2 times 1, 2, which gives us a to be equal to 4. So you can see that we have got the same formula, the same answer, and therefore 2x minus 3, which is our a is 4, positive times negative is negative 1 over x minus 3. So this is how we work out any partial fraction to which its linear factor, its denominator has got 2 or 3 distinct linear factors. What do we mean by a linear factor? It's a situation where this variable in the denominator is not raised to a power more than 1. Thank you for watching, and I hope the lesson has been very maybe to the to the point. If you have got any comments, please make sure to drop those comments in the comment section. And maybe before I close up this video, let me just also give you some questions which you can work out. Please make sure that you try to work out these questions, and the expected solutions I've already added in that side so that you can see and compare if at all what you would have done is right or wrong. But if you have got any questions about those questions, please you can drop a comment in the comment section, and I'll be able to attend to you. Thank you for watching.